All right, so the first thing I need to recognize about this acid is that it is a weak acid. So even though they didn't give me a Ka, I will need that information. So I'm going to check that in the book. And I get 4.9 times 10 to the minus 10. All right, so now I'm going to need to write an ice table. And I'm going to do that with HCN, dissociating to lose a hydrogen. And I know how much HCN I started with. I didn't start with any of the ions, minus X and plus X, add them up. All right, now I can solve for X using the Ka equation, which would be products H plus and Cn minus on top, HCN on the bottom. X squared and 0.15 minus X. All right, to solve this without a quadratic, I'll need to assume X is small, which means that 0.15 minus X is about the same as just 0.15. Solving for X by itself, I get X squared equals 0.15 times 4.9 times 10 to the minus 10. And then to get X, I'll just take the square root of that. All right, so my X is 8.57 times 10 to the minus 6th. Okay, there we go. All right, I will check that X is small just to make sure. So remember that would be comparing X to the 0.15, which is where I ignored it compared to, and times 100. And that should just be less than 5, which it will be. .005, so we're good. There. All right, so now I just need to look at what that means and what things it asked me for. It asked me for the concentration of HCN, which would be 0.15 minus that really tiny number. I'll put it in my calculator and see, but I bet it's going to still be 0.15. To 2 sig figs, yep, still 0.15. So the HCN is 0.15 molar. The H plus at equilibrium would be X, so that's 8.57 times 10 to the minus 6 molar. The Cn minus, also X. And then the last thing they asked me for was OH minus. For that, I don't have any OH minus in here, but I can get that from my H plus concentration by remembering that 1 times 10 to the minus 14 is Kw, and that would be H plus times OH minus. So I'm solving for OH minus would be 1.1 times 10 to the minus 14th divided by X, 8.57 times 10 to the minus 6. I get 1.17 times 10 to the minus 9th.